Morning.
Morning.
Was it raining?
It's spring, but on the way here, it started pouring.
Morning. So this is almost like the last week, for the last week, so we, according to my plan, we probably should just quickly go through chapter 8 and 9. That doesn't leave a lot of time for us, so I try to see if we can manage within the Thursday. All right, we already went through some of the content, chapter 8 about arbitrage and the term structure of interest rate. We will not have enough time to went all the way to the financial derivatives. But you will be studying derivative if you are going on to your classes in investment and financial products. So I'm gonna skip the later half of chapter 8, only go through chapter 1 through 6. Okay, we went through the introduction part, the terminology for arbitrage and the concept of arbitrage. I'm gonna try to go through quickly because last time when I tried to review slowly, I realized I don't have a lot of time. In 8.2, we're talking about arbitrage, and there are a couple of scenario arbitrage with T-bill arbitrage, with with exchange rate, currency exchange, and arbitrage about any other products. And those are a couple here. And then 8.3 talking about term structure of interest rate. The main thing is talking about spot rate and how do we determine the spot rate. How do we identify spot rate when the coupon bond is offered? If we offer coupon and identify the spot rate, the method. If you're given the yield rate, yield is really the interest rate for a longer time period. Yield rate is, for example, yield rate Y3 representing your investing from. This is a 5% par value bond. So you have an annual coupon. All your coupon cash flow and your final redemption value are using the same interest rate calculation when you're discounting it. That's your Y3. But spot rate, assuming that for different time lengths, you're using different interest rate, which is why it's called spot rate. So with the yield rate, you should be able to calculate or determine the spot rate. And we did that. We calculate with Y1 that equals spot rate R1. With Y2, you can strip off the cash flow at the first year and also at the coupon time. Year 1 and year 2, you can determine the spot rate. And then once you determine the spot rate for R1, R2, you can determine the spot rate for R3. This is all annual which you can use to apply to determine the spot rate. And that is done in 8.3. Now, once you have all your spot rates, now you have your term structure. You can determine something called a spot rate curve, the spot rate as Y value and the time of the year as the X value. Now we can also determine something called a theoretical forward rate. The purpose of forward rate is allowing you to predict if you want to invest 2 years from now or 1 year from now, invested for that many years. Basically, is your future investment from time S to time T to time S. What's your expected interest rate for that time frame? So you can think of forward rate as spot rate in the future, predicting what happened in the future. That's the theoretical forward rate. We went through those. And then we went on all the way to 8.4 about loan with floating interest rates. Floating rate means that you're not going to have a constant interest rate. And therefore, the interest rate at any given time, it depends on the market interest rate. For that, you have to compare your interest rate with some like index interest rates compared to one of the popular one is the LIBOR. We have the terminology here is the London Interbank Offered Rate. This is widely available. You can find it out. You need to compare your rate with the prime market rate. There's also basis point. If we are not gonna be offered the LIBOR rate, and then we wanna know it because we wanna compare that to say how much we are being offered above or below the LIBOR rate, and then the comparing point, we use the basis point. Okay, so 1 basis point is 100 basis point is 1%. And that's some of the terminology you might see in your finance class. Let's just try to introduce that. This is an example talking about loan with floating interest rate. And so we're talking about one company trying to borrow. They borrowed the 5,000 from the bank. So they want to pay the interest rate due at the end of the first year. So they're being offered the interest rate. The interest rate is LIBOR plus 125 basis point. So from there, you can see the interest rate are not going to stay the same. It depends on the LIBOR rate and plus 125 basis point for the year. So the question that we're halfway through this question, not some we're ended. There are 2 questions. A is determine when do you determine your interest rate and when do you pay it. Normally each year you determine the interest rate at the beginning of the year and you pay it at the end of the year. The second question is to suppose that the 1-year LIBOR rate for May 2014 and for May 2016 is given. Suppose we're given the 0.53% and 1.8% for those 2 years. What should be the amount of payment? Notice that the 2014 is a payment of the interest, outstanding interest, but for for April 30, 2017, that's the end of the loan term. So the company have to pay the interest plus the principal. So the payment on April 30, 2013 will be way more than the previous payment. And those are the answer. So for 2014, well, April 2015, the payment should be the principal, which is 500,000 multiplied by the interest of 0.0178. So that's just outstanding interest that we need to pay by the end of the year. Now, the end of the 2017, the payment is interest plus the principal. So you take the interest rate of 3.05% multiplied by the principal, that's your interest payment plus the principal. So that you pay off the entire loan. And that's why the payment is a lot larger on that day. Any question? Okay. So we're gonna move on to other example. I talk about in chapter 8 is because we want to be able to arrive at a topic that's called swaps. So all these are terminology and example about when you wanted to have a fixed rate, but you were being offered the floating rate, or when you wanted to pay the floating rate being offered a fixed rate. How do you change that? How do you work around that? That's the swaps. But in the meantime, let's finish the example on floating rate. Here's another example on floating rate. We have a different payment each year. Suppose this is a loan for 7 million. At the end of first year, the company want to pay the interest plus 1 million of the principal. At the end of second year, the company want to pay the interest due plus the 2 million principal. So we're reducing the principal and not pay the interest in the meantime. And then the final payment at the end of the third year is pay off the entire loan. So let's see what would be want to determine the payments here. So here we are. Let's talk about the payment. Depending on the interest rate, you're given that 1 year prime interest rate was 2.85. This is talking about the third years. When I ask what would be the third year's payment, the 2.85 is the prime interest rate. So that's compared to what you're being offered we have to take off up from that rate plus the 230 basis point. So the actual interest rate is going to be 2.85 plus 2.3. The actual interest rate for the company is 5.15%. So at time three, the interest will be the 5.15% times the outstanding balance. There are already some balance paying due. The 7 million is being paid 1 million at the end of the year one, 2 million at the end of year two. So you only have 4,000 principal. The outstanding balance is now 4,000. So your 4,000 multiplied by the interest rate, that's the 206,000 in interest. But then you also have to pay the 4,000 in the principal. So interest plus principal, the total payment is 4 million plus 206,000. Any question? So these are floating payment because you have to look at the interest rate for that year to determine your actual payment. All right, so let's talk about swaps. See, we mentioned that a swap is a contract. So what is a swap? Swap is a contract in which the party agree to treat sequence of cash flow arising from financial instrument. Now we're going to focus on one type of swap, which is the one that in the FN exam that's being referred to the most often. We're talking about interest rate swap. And you can have a different type of swap, like you want this product and the other side want the other product. You can trade the product, or you can trade other financial product. And here we're going to talk about interest rate swap. It's a contract between two parties in which each party agreed to pay the other party a sequence of cash flow over a specified time. So the term, like 5 year, 4 year, that's a specified time where each party is defined as the interest due on a specified amount. It's called interest swap is because payment is paid on the interest rate specified in the contract. So for example, let's look at example. Say EFG. This is a company, they enter a 3-year loan agreement where it receive 1 million at the beginning of each year. EFG Corporation agreed to pay the interest due at the end of each year calculated using the 1-year spot rate as of the beginning of that payment period. So spot rate is the floating rate in this case. At the end of the 3rd year, EFG will repay the 3,000 it had borrowed and along with interest due. Find the amount that EFG paid to repay this loan if the 1-year spot rate experienced at time 0, 1, 2 were 5.04, 4.82, and 6.13 respectively. So this is still an example with floating rate. You're going to calculate a cash flow, and obviously you're going to take the balance of that year. They borrow 1 million per year, so the outstanding balance being changing. It's 1 million, 2 million, and 3 million for time 1, time 2, and time 3. Use the interest rate multiplied by the outstanding balance. That's your interest payment. So this is the floating rate payment. Okay. Now this is still an example of floating rate payment. Suppose the company EFG they want to fix the interest rate. They don't want to. I mean, for planning, it's easier if the interest rate is already known at the beginning of the term. So, but maybe they cannot get one that's on the favorable term. Maybe you can always determine a fixed rate loan, but the bank offer like 10% or 8%. You're like, that sounds so good. So since loan payment, you want a lower interest rate, and that's why compared to 8% interest rate, maybe the floating interest rate of 5.04, 4.82 now is not so bad anymore. So that's why even though for planning we prefer fixed rate, sometimes we have to settle or compromise for a floating rate. Are we okay so far? But then you still want to have a fixed rate. If this place cannot offer you, like you can do an interest rate swap with someone else. All right, so here is the situation. We finally have the example on the interest rate swap. So on the same day they enter the 3-year loan agreement to borrow the money, they enter a 3-year agreement with a third party, HIG Financial. What they do, they are doing an interest rate swap. So this is not a loan, it's separate from the loan agreement that EFG has already. So what they wanted to do is try to achieve a contract that actually offer possibility for a fixed rate. So at the end of each of the 3 years, the two parties will pay the other party the amount of equal to the interest calculated using the 1 million, 2 million, and 3 million as principal in that order. These amounts were chosen to mirror the outstanding loan balance at the end of each year EFG's loan. EFG will pay using a fixed rate of 5.51%. See, so this interest rate is not too high compared to the floating rate. Well, how do we know the floating rate? You can use the spot rate at the time to predict what happened. So here we are. So EFG will be paying a fixed rate of 5.51. AIG will pay using the 1-year spot rate at the beginning of the year. So in this case, EFG will be receiving the floating rate and paying the fixed rate. Sounds familiar? So if you are receiving a floating rate on the other side for the loan agreement, you are paying the floating rate. So that maybe now in effect, you're actually paying a fixed rate if you combine the two contracts. Okay, so let's look at what happened. This is the payment, the 6th payment took place in this interest rate swap. A 1-year spot rate was 5.04. We're using the same interest rate as we mentioned earlier. So HIG will pay EFG with at time 1, time 2, and time 3. You can see those are all the calculations. The HIG is paying the floating rate. Now EFG in this interest rate swap, EFG is paying a fixed rate. We're using the 5.151% for all the payments at time 1, time 2, time 3. Do we have any questions? And I try to make a picture of what do they receive. The error is like EFG is receive this, and then HIG is receive it. They're paying each other. So if we're paying you a lot, you're paying me a lot. Maybe since they have to pay each other, maybe they can just find out how much difference, and they only pay the net payment. That's the idea. I put the interest rate on the picture so you can see those calculations are being calculated using the floating rate. On the other side, HIG is receiving the fixed rate. Okay, so now the actual payment is the exchange of the cash flow is net cash flow. And you can see sometimes EFG is paying more, and sometimes the HIG has to pay. All right, so now let's talk about terminology. That's the example on interest rate swap. So the two parties are called the interest rate swap counterparties. The term and date is being called the settlement date, the date when they have the agreement. And the payment are usually periodic. The length of time between the two consecutive settlement is called settlement period. All right, and then the specified amount that we calculate the interest rate is called notional principal. These are all the terminology we read in the question, like notional principal, notional, what do they mean? This interest rate we just explained the example is called plain vanilla swap, which basically is swapping the fixed rate for a floating rate. The one that's paying the fixed rate is called the payer. The one paying the floating rate is called the receiver. Okay, and the fixed rate that's being quoted in the contract is called the swap rate. Because in the contract, you cannot predict the future spot rate, but you can definitely predict your fixed rate. The fixed rate will be calculated based on the current spot rate on the market. Okay, the net swap payment. We mentioned the net cash flow. That's our net swap payment. Okay, now following that example, we can calculate the net swap payment. See, at time 1, EFG is paying HIG the net swap payment. At time 2, EFG is still paying HIG because the fixed rate seems to be higher. And then at time 3, the interest rate finally is a little bit higher, so HIG has to pay EFG. Any question? So overall, you can see it's hard to tell which one actually paying more. Technically, their present value of all the cash flow should be 0. So nobody is paying anybody more. They have equal present value. Okay, so this is a calculation of the net cash flow. We're looking at who is higher than who. So you can see who's having the higher payment among the two parties, and that's when I have to pay the net cash flow. All right, so there's a net interest rate payment. This is combining the two contracts. So if you look at the contract from the loan and the contract for the interest rate swap, the two combined, instead of having subtraction of two payment, you're adding in the one that EFG is paying. So in altogether, it's the total net interest payment for EFG is a fixed rate. So by applying the interest rate swap together with the loan payment, the loan contract, they actually are paying the fixed rate. Any question? And that kind of made it easier for financial planning for that reason. Okay. All right, so we would have to figure out a way to, you see in the example, we have the swap rate that's given. In fact, most of the time the swap rate in our calculation, swap rate has to be calculated by both parties to determine the rule for the swap rate is that the total present value, the net cash flow, the total present value should equal to zero, meaning that the payer and the receiver, none of them are losing money, considering the current at the beginning of the term when they sign the contract. At that time, using the spot rate available, they will find the swap rate that either party are not losing money. They have the same present value. So the net present value together is zero. So let's look at how do we calculate the swap rate. Let me try to explain this well, because we were going to do some swap rate calculation on our own. So we have to understand the reasoning behind how do we determine the swap rate. For example, in that first example that we had, suppose the swap rate R1, R2, R3 is given in the first scenario. So now we have the outstanding balance of 1 million, 2 million, 3 million. We're going to use our spot rate. You can calculate the floating rate interest rate payment. Now we want to calculate a spot rate R. The last line of the question is finding the spot rates. So suppose R is a swap rate. We want to determine how with the payment, the rate R that is offering the present value, total present value for both party equal to each other. So here we are. So here we have the net present value, EFG's cash flow. So for EFG, in the swap rate contract, EFG is paying the fixed rate. So the 1 million times R, 2 million times R, and 3 million times R are the cash flow at time 1, time 2, and time 3. So the present value of those cash flow are divided by the 1 plus RT to the T power in the denominator. So then the top line explaining that cash flow for EFG, present value of EFG's cash flow. And then for HIG, which is paying a floating rate, so you might ask, what is a floating rate? It's the interest rate, forward rate at time 0, time 1, and time 2 to 3. So year 1, year 2, and year 3, what's the interest rate for HIG? So you're going to take your balance, multiply by the floating rate, that's their payment cash flow, and you have to discount it back to time 0 using the same spot rate. The two have to equal. So we're going to set it equal and solve for the R. You can see in the entire equation, if you want to solve for the R, you have to be able to find out those F, the floating rate. F01 is the same as spot rate, but F12 is not. And we have to review the spot rate calculation. Basically, F12 plus 1 is equal to it basically let money grow from 0 to 1. The growth factor is 1 plus R1. From 1 to 2 is 1 plus F12, which equal to letting money grow from 1 to 2, which is 1 plus R2 squared. Right, that's the calculation. Same calculation from year 2 to year 3. From year 0 to year 2 is 1 plus R2 squared. from year 0 to year 3 is 1 plus R3 to the power 3. So you discount that back to time 2. That's that division, and you subtract 1. It's finding out the interest rate. So that's F23 calculation. Determining the floating rate and plug into the equation, you'll be calculating the R. So letting the cash flow, the present value calculation, the first one equal the second one, and setting them equal, solve for R. Any question for the calculation? So we're really setting the two present value in the first equation, second equation, we set it equal and solve for the R. It does involve a little bit of calculation of the floating rate. So you can see the process is kind of a lengthy process since it involves so many numbers. We find out the swap rate is 5.51%. That was the percentage in the first example. So that's why this is a swap rate. The swap rate example for kind of echo what we already were using as a swap rate. All right, let's look at some of the some more example of the calculation just to get used to the calculation. And suppose we have a level notional amount. So every year we have 80,000. And then we say determine the swap rate and the anticipated net swap payment at the end of the fourth year. Today's swap rate are given. So we have a swap rate, we have the term structure of the interest rate. Now we want to calculate what will be the proper swap rate if we're entering a swap rate agreement. Okay, so here we are. Now, assuming the swap rate is R, so you have your outstanding balance times R. Those are the cash flow. 80,000 times R is cash flow at time 1, 2, 3, 4. You discount them all back to time 0. That's the first calculation. That's all the present value of all the fixed rate interest rate cash flow, right? And then we're going to talk about the floating rate cash flow. For that, you have to use all your spot rate. You have to calculate your floating rate. Here are the floating rate calculations. And then putting in the floating rate in your equation, you're going to solve for R. So we're setting the first equation equal to the second equation, solve for the R. And the R equal to 3.10. So somewhere in between the spot rate, right? And determining a swap rate. Any question? The calculation. We're going to talk about faster way of solving the swap rate. But for now, we're trying to follow the idea. Like pretty much you're trying to replacing the floating rate with a fixed rate. What will be the appropriate fixed rate? And that fixed rate is called swap rate. So let's look at the calculation. Now that we know what we use for R and what we use for the floating rate. F34 is 4.79%. So for the floating payment is 80,000 times that rate. It's giving you the cash flow. Now for the fixed rate, we know the rate is 3.1024%. So we're going to multiply that with 80,000 to get the cash flow. So that the swap rate agreement is whoever is larger, in this case will be the floating rate. So then that party that would have to pay the net cash flow. This is explaining the question, what will be the anticipated net swap payment at the end of year 4? That was trying to answer that question. Questions determining the swap rate and determining the forced cash flow forced payment. Any question? So that finished the swap rate example. And let's talk about deferred swap. What's a deferred swap? It's when you are having a contract of the swap payment, but you didn't immediately start the swap. So you were deferring the swap payment to a future time. In the period of time until the first settlement period or the first payment period is called the deferred period. Swap term for the deferred swap start at the beginning of the deferred period and then on the last settlement date. Okay, so instead of having start swapping their payment at time 1, time 2, time 3, time 4, if you defer for 2 years, you're going to start from 3 and then 4. You end up having a 2-year swap agreement, but you are determining the rate at time 0. So that's why it's called deferred. Your contract is made earlier, but the swap are later So we didn't immediately start at the term first settlement time. That's what's called deferred swap. So even for that, we want to be able to determine the swap rates. So it's for financial planning, it's possible we are not immediately starting the swap. Maybe you are planning to have a swap in according to a contract with your loan. You want to start swap a year later or 2 years later. So that's why deferred swap is meaningful. So here we have Don enter a 5-year interest rate swap with a deferred period of 2 years and level notional amount of 250,000. Settlement period is 1 year. Don will swap a fixed interest rate or a variable interest rate. So receiving the variable rate and paying the fixed rate. The variable interest rate will be the 1 year spot rate at the start of each settlement period. Okay, like it's kind of similar to the previous example. At the beginning of the 5-year period, the spot rate are as below. R1, R2, R3, R4, and R5. These are all the spot rate. Calculate the swap rate for this contract. So it's deferred 2 years. So then we start making a swap exchange at the 3rd year. That's what meaning. So we have 5 swap rates. So this means we defer 2 years. Then we're not making the first swap. We start the swap at year 3. So that's why we have 3 swap payments. Okay, so starting the 3rd year, we start exchanging the interest rate. That's why it's called interest rate. So the interest for the fixed payment is 250 million times R. We are discounting using the spot rate at years 3, year 4, and year 5. R3, R4, and R5 is being applied. And then now you also have to determine the floating rate, which is why you're gonna need in the 3rd year is from time 2 to 3. I mean, the 1st year is 0 to 1, 2nd year is 1 to 2. So the 3rd year is 2 to 3. So you need a floating rate for forward floating rate of 2 to 3, 3 to 4, and 4 to 5. And then those are being calculated right here. And then we put it into the calculation solve for the R. In the equation, in the first line of equation we saw, we put the R, it's going to be a division. See that division that we find out the swap rate equals 7.077%. Any question? That's support. So all of those, you can see if we did not defer, we would have 5 swap rate calculation. There are 5 on the left, 5 on the right, so it will make the numerator and denominator both longer. But in this sense, the calculation for the swap rate is very similar, deferred or not deferred. So this is an example on use the interest rate to lower the loan payment. So here we have 2 persons. Ryan borrowed $100,000 for 5 years with annual interest rate. He was offered a choice of a floating rate of LIBOR plus 1.5 or a fixed rate of 8%. Ryan preferred fixed rate but accepted the floating rate. Why? Right, you are borrowing, so you would prefer lower interest rate. So maybe the fixed rate 8% is not very favorable. That's why he compromised with the floating rate. Maybe at the time the LIBOR is not as high as 8%. So maybe you may prefer one form of the interest rate, but you're forced to accept the other one because which one's on your favor. Naomi also borrowed $100,000 for 5 years with annual interest rate. The rate available to her was floating rate LIBOR plus 1% or a fixed rate of 7%. Although she preferred floating rate, she chose to accept the fixed rate of 7%. So maybe the LIBOR plus 1% is high for her. So we have to question whether it's the LIBOR or the fixed rate. Essentially, when you borrow money, you prefer the lower interest rate. Maybe for her, the fixed rate of 7% is much lower than the floating rate. So I guess the current floating LIBOR might be a 7.57% or something. So I'm trying to guess why they make those choices now. Now, since they both have their preferred format of interest rate. So Naomi preferred floating rate, so then she entered an interest rate swap with another bank in which she swapped fixed rate of 7%. So now she has a fixed rate of she's paying the 6% in fixed rate for floating rate LIBOR plus 0.8%. So that's a little bit more favorable than the original bank offered LIBOR plus 1%. So LIBOR plus 0.8% is a little bit better. Ryan too enters interest rate swap with the bank in which he swapped the floating rate of LIBOR plus 0.8 for a fixed rate of 7.1%. And that's also better than the 8% originally offered. Right, the reason that he is forced to accept the LIBOR plus 1.9 initially is because the fixed rate was too high. So he would be more happier if it's a fixed rate of 7.1%. So here what happened was then Naomi and then Ryan, they each have their own lender. Okay, and then they had Naomi wanted a floating rate but had to accept the fixed rate, and then so she swapped with the bank for a floating rate so that she can pay a floating rate but receiving a fixed rate. Now she then can give the 7% fixed rate back to the lender. So in effect, the in and out of 7% makes the actual payment for her is a floating rate. Now for Ryan, he preferred a fixed rate, but then he can't get on the favorable terms, so decided to accept the LIBOR plus 1.5%. And then he had the interest rate swap. It was he's receiving the floating rate and then paying the fixed rate. Any question? So this is a scenario where swap choice is a good choice for some person. All right, so then this explains the benefit for each party. I think I kind of went through all these. And then let's talk about the formula. So far, we realized that we do have to calculate interest rate swap. And then sometime the calculation we were saying earlier, they're kind of time consuming in the sense we have to calculate the forward rate. For each question, you may end up having to calculate 3 or 4 of the forward rate, and then you went out and calculate using a big division to calculate your swap rates. It's doable, but maybe a little bit time consuming. We're looking for a better formula. This is a 8.6 focus on the calculation formula. Okay, so here we are. Now, how do I derive a shorter and simpler formula? We start by simplifying our notation. So here we're going to see, suppose we have, we use the TK minus 1 to TK to represent the settlement period from the TK minus 1 to TK. And we use QK to represent the notional amount of payment or the principal for that time period. And R is the swap rate. Okay, so this just it's still like a more notation that we're trying to make the notation that we had earlier shorter, so the equation is easier to identify. Okay, so with the payment period, and then we're gonna use a notation PK, PT. PT represent 1 plus RT to the negative T power. So this is really a present value calculation of $1 discounted back to time 0. So PT is a price formula. The price for $1 at time t discounted back to time 0. And therefore, of course, P0 we put 1. And so then if you want to discount anything, instead of divide 1 plus RT to the power t, all you have to do is multiply by PT. So the definition of PT made it a little bit shorter on your formula part. Remember all those big divisions, divide 1 plus RT to the power 1. Divide 1 plus R2 to the power 2, divide 1 plus R3 to the power 3. Those are becoming multiplication P1, P2, P3. So then the payer's cash flow will be QK times R times PTK. Now the receiver's payment will be the QK FTK at FTK minus 1 TK times PK. So the net cash flow on both parts becomes a little bit shorter because the notation of PTK. Right, so now we realize that we sometimes use Q instead of QK. We may have a constant notional amount, and the equation can be even simpler. Now moving forward, what we're gonna do is we set these two payments to present value calculation. The summation of QK RPTK would equal to the summation of QK FTK minus 1 TK times PTK. So these two are setting equal. Solving for the R would be this division. That's the same writing that we had earlier. So why do we want to use this? Because we have more simplification to do. Now, the forward recalculation is from TK minus 1 to TK. So you're going to find the growth factor from 0 to TK. That's 1 plus RTK raised to the power TK divided by the growth factor from 0 to TK minus 1. That's in the denominator. This division essentially is, remember PT or PK represent a reciprocal. It's definition for PT. So it's a reciprocal relation. So that means there's 1 plus F actually equal to PT K minus 1 over PTK. Okay. So then the calculation that we need for the F in the numerator, we need the forward rate from TK minus 1 to TK. That forward rate actually equal to PTK minus 1 over PTK minus 1. And then we also have to multiply that by TK. So the last line of calculation explains that in the numerator, you actually are going to have a summation of QK times PTK minus 1 minus PTK. That looks like this. All right. So what happened is now the formula looks a lot more concise as long as we have all those PT, which is a price for a future $1 calculated now. The price, the P is a price formula, price value. Okay, so now a little bit forward. If the QK are not variable, so if the QK all equal to the same notional amount, which is the case most of the time, even when QK are not the same, they tend to have some pattern to it. So this formula offered a better way for calculating the forward rate. Cancel the Q in the numerator denominator in 8.6.9. We realize that R equal to PT0 minus PTK over summation PT, which is all the price, which is the reciprocal function for the growth factor added all together. And I offered a quicker formula for the computation. All right, so that is going to be our swap rate formula. Let's see if we can apply this formula for a couple of different scenarios. We're going to revisit many of the calculations that we did earlier to see if the formula offered a better way for the calculation. So let's look at this one. Okay, so this is the example 11. We have the 50,000, that's the notional amount is being the same. And this is talking about making a quarterly payment. So that's made payment on 3 months, 6 months, 9 months, and 12 months. And we have a swap rate offered here. We're determining the swap rate expressed in notional interest rate, convertible quarterly. Also find the anticipated net swap repayment at the end of the second quarter. So we're trying to find the calculation of the payment and then determine the swap rate. So let's try to see how is that calculated. So according to the formula we have here, right, you're going to identify those time, and the time in finance is number of years. So if we're talking about 3 months, 6 months, 9 months, 12 months, this is a quarter, a year, 2 quarters, 3 quarters, and it will be 0.25, 0.2, 0.5, 0.75, and 1. So that's a denominator. Okay. Numerator, according to what we have, is the time swap before your first T0 is before T1, right? Time 1 settlement ahead of the first payment minus PTN, which is your last payment time. And then subtraction. So in this case, we have the denominator has P0 to 5, P 0.5, 0.75. So before the 0.25 is P0. So numerator should be P0 minus P1. So we need all those number. And then now it's time for computation. In our interest rate quoted, we're gonna calculate 1 plus interest rate for that time period raised to the power t. So you can see the power is negative pt equal to 1 plus rt to the negative t. So the exponent is negative of the time for every pt, that t could be 0.5 or 0.75. And then those are 1 plus r, those are the interest reported in the chart. And then we find our swap rate. This is a quarterly swap rate. We multiply by 4 to find the swap rate exchange, expressed as a convertible quarterly interest rate. Any question? So this is the example 11. Let's try a couple more examples and we can go back and look at our later question. So here we have the second quarter payment. The floating payment, the fixed payment is the principal multiplied by the interest rate. The R that we had is this R, that's the 0.00429. For the second quarter payment, you multiply that R with the 50,000, you get 214.63. For the floating payment, you have to multiply by the forward rate from 0.25 to 0.5. That's the second quarter. So you multiply 1 plus R to the 0.5 power over the 1 plus R 0.25 to the 0.25 power. That's how you get that floating rate. You multiply by the principal, you will get the floating payment. Any question? All right. Another example is revisiting the example 8, where you have a deferred payment, and we want to say if you defer 2 periods, that means you are paying at time 3, 4, and 5. So your denominator equal, you need your P3, P4, and P5, and your numerator is 1 period before the P3, that's P2, minus the P5. That follow the formula that we had in the in this formula. That's the formula we're gonna follow for the swap rate calculation. So this is the swap rate applied for when you have equal notional amount for every settlement period, and also you already have your swap rate. So having swap rate calculating the PT, it wouldn't be a big problem. So we're gonna do that with our exercise question for today. I use this question for attendance. So here we are. This is one of the FM exam. We were given the swap rate. See R1, R2, R3, R4, and R5. That's your swap rate. The question is, suppose you have equal notional amount as most of the time for the swap rate contract. We want to find the fixed rate, assuming the notional amount is the same, assuming it's all 100,000. Okay, if the swap rate and annual payment was the fixed rate, we should pay. All right, so it says here based on the future LIBOR rate, and then the spot rate that we quoted, I think, will be predicting the future spot LIBOR rate. So let's use this example and do a calculation. So we kind of see how the example works. Okay, so we want to calculate R. And let's write down the formula. R is equal to, and the denominator is supposed to be summation of all the PT for all the time that's in the term. This is a 5-year interest rate swap. So you're gonna need all the P1 to P5 all added together. Numerator is supposed to be PT0 minus PTN. In our example, the denominator would be like this. You write it faster. So the number is going to be P1 plus P2. I mean, it's supposed to be a lower, smaller letter. Smaller index 1, 2, and then P3, and then P4, and then P5. This is the price per $1 of discounted at time 0. It's supposed to be like this. There's a 5. It's supposed to be. Okay, and the neighborhood is supposed to be one period before the first one is going to be P0 minus P5 in this case. Now you wonder what was P0? It's the price at time 0. In this case, it's probably 1. Because we're talking about the entire time frame. All right, and then you can see you're going to calculate the interest rate. We gotta know how to calculate each one of these. And P1 is equal to, this is the calculation, 1 plus R1 to the power of -1. Trying to explain the formula, and you know there's our R1. Okay. And then the calculation for P2. It's a price of $1 at time 2, just kind of back to time 0. So it's 1 plus R2 raised to the power of -2. Right, so you can see this is going to take a while first. I mean, I'm going to go dot, 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 dot. We do the same. And then what's P5? P5 is equal to 1 plus R5, which is 7.5% raised to the power of -5. That kind of explains how to do the calculation. Are you okay? So now, an easy way to do this, if you have Excel, I mean, you can definitely do it by hand. I'll do it by hand. I feel like we don't always, in this kind, we don't use Excel that often. Let me just type it up, the calculation, put it into a calculator. All right, so here are the calculation. R is equal to 1 minus P5. What's P5? P5 is 1.075, right? 1 plus R raised to the power of -5. So P5 divided by P1. P1 is 1 plus R1 is 1.04. You're going to raise it to the power of -1. Okay. Discount back to time 0, and then P2 is 1.045. R2 raised to the power -2. I mean, discount, the term structure means that interest rate is for that time period. If you have a longer time period, you gotta have a different interest rate. 1.0525 is investment for 3 years. So you discount to -3, and then that's 1.0, it's the fourth one, 625, you raise it to the power of -4, and then 1.075 raised to the power of -5. That's the whole calculation. I hope it's okay. Type it into the calculator, and that should be your answer for the swap rate. I'll leave it there. And you guys try to finish the rest of the calculation. It certainly will be faster if you can use Excel, but we can't really rely on Excel. Most of the time, what we have on the FND exam is just your own calculator. Whichever calculator is okay. So we need to try to learn to handle it without looking with your program. So now you do your calculation and type in computation. Spot recalculation of 1 minus P5 divided by summation of P1, P2, P3, P4, P5. Give you the interest rate. All these number is comparable to each other. I already have the formula. Calculator. That's what I have. You have your answer. Okay. Yes, I think it's 7.2. Roughly 7.197, so around 2.72%. That's the swap rate example. I think it kind of explained how to calculate the swap rate. It's a little bit quicker. And this way, you don't have to have the full rate calculation. Even though full rate is helpful, but we don't always have to calculate it. All right, this is another example about the 1 million, 2 million, 3 million example. In this case, it's not constant. So you do have to involve in there, but you can cancel some of the common factor. You can still use your P1, P2, P3 in there. So this is applying this formula. Realize this one does not work anymore. This only works for level notional amount. If the notional amount is not level, you're gonna have to apply this one. So it's applying 6.6.8. But you have QK multiplied by PK multiplied by. Okay, so its numerator is going to be a big summation, and that's why we did this through that method. But it's still helpful to analyze with a shorter notation. So 8.6 offered a better way to analyze the swap rate calculation. All right, the rest is about the different things in the market. So we're gonna really bit and like that one. Market value of interest rate swap. I think it went through this. Let's skip section 7. Mainly, most of the question that we were saying in the FF exam is swap rate calculation and how do you use them to determine your payment. If you want to, so this example on explaining the market value of the interest rate swap. It depends on the actual interest rate on the market. So I'm going to finish the chapter 8 there and then went on for the chapter 9. So then we won't lose too much time. Any questions so far? Are we okay? So what I'm going for with all the first six section of chapter 8 is that we would find a more solid understanding on how to understand swap rate and how to calculate it. Swap rate is really the main thing I want to explain. Let's talk about chapter 9. We're going to focus on 9.2 and 9.6 because they are two of the idea concept that we do have to learn and understand. 9.2 is duration, 9.6 is immunization. And both of them are related to risks. So now, just like all the other chapters, 9.1 is introduction of what basic entire chapter is. In between 9.2 and 9.6, there are other topics. So leading from 9.2, we're really going for the immunization idea. When we talk about immunization in finance, we're really trying to immunize against any risks. If you're talking about money, the risk is interest rates. Because when you are starting your investment, you have a situation of the current interest rate. If the interest rate is changing toward a direction that's risky for you, you might want to find a way to handle that. And that's why we talk about immunization. Now, 9.2, we talk about the term duration. Duration is often something you want to calculate for certain cash flows. So let's talk about duration. Okay, so let's start with the idea of what is duration. Duration tells how much price might change when the interest rate change. So again, it's about evaluating how interest rate will affect our present value. So it measures sensitivity to interest rates. For example, suppose the duration is 5. What does it mean? It means if the interest rate changed by 1%, it will cause the value of your cash flow to increase or decrease by 5%. So That's the meaning by time. So duration kind of give you an idea how things are gonna change. There are two common calculation. One is called Macaulay duration. The other one's called modified duration. So the main thing is no matter which one is being mentioned, we want to be able to calculate that. Let's look at examples. I'll start with Macaulay duration. Now, this is a cash flow on the line, the timeline of the cash flow. At year one, you have 10. Year two, there's cash flow 2, and then year three, there's cash flow of 1,030. So what we try to find out is what is the average time of the payment that the payment are made. You can see the payment has 1, 2, and 3. This 3 has a bigger amount, so our idea will be I will be leaning towards 3. So there are a couple of ideas. A1 says since the time payment are 1, 2, 3, maybe the average is equal to 2, but that's not, since the payment are not level, so that doesn't really make much sense. The second idea is maybe we can use the cash flow to weight on the time. So in time 1, the weight will be 10 over 1,060. At time 2, the weight will be 20 over 1,060 and time 3. So with this, to calculate the 2.96. But these calculations are not taking consideration of some of them are later payments, some of them are earlier. So maybe it doesn't take into consideration of the interest, the time value. So the third one is what Macaulay duration is. So we're going to use the weighted average of the time to figure out the duration. Exactly what is duration means, kind of like figure out the average payment time, kind of like the weighted average of the time. The weight is the important part. The weight is really the present value. So you have present value of the total cash flow. Now, in that present value, you want to find out what is the present value of the first cash flow, what is the present value of the second cash flow, what is the present value of the third one, in comparison of the total present value with that percentage. That's the weight for each time. For example, for time 1, the weight is 10 times the V is a discount factor, 10V over the present value. And that's how heavy or how much weight the time 1 is. Time 2 is 20V squared over the total present value. And time 3, you can see it's having a heavier percentage because the amount is larger, but then you have to discount the fact that it's at time 3. It's much, much later time. So then the total calculation will give you the actual Macaulay duration calculation. Any question? Smooth explanation, try to go through the idea of the Macaulay duration. So the Macaulay duration of the set of payment is the weighted average of the times of the payment that were the weight of the payment at the time t is equal to the present value of the payment at the time t divided by the present value of all payment. Okay, so here is the little formula for Macaulay duration. If the CT is being made at time t. So CT have to discount all the way back to time 0 to find the total present value. So in the denominator is the total present value calculation. In the numerator, every cash flow is multiplied by the appropriate times, but then they add it all together. So that's why it's called a weighted average of the times. Any question? That's the Macaulay duration. And let's look at example. Example 1, suppose you have a cash flow. It's the same as what we had in this example. Remember, we were talking about having really calculated. Let's finish the calculation of this duration. We have a C1, that's $10. C2, that's 20. 10, 20, 1,030. So C3 is 1,030. You can actually put this into your financial calculator and calculate the present value. You're gonna end up having present value at 971.16. Now it's time to calculate the weighted average. So the first cash flow is 10. We divide by 1.03 to find present value, and then you divide by the total present value to find its percentage for 1. Right, for the number 2, the actual present value for that cash flow is 20 over 1.03 squared. That should be divided by the total present value. And the third cash flow is 1,030 divided by the the interest rate to power 3. 1 plus interest rate to the power 3 because it's third year payment, third year cash flow. So that discounting back to time 0 and then divided by the total cash flow, total present value. We got 2.96. That seems to be the same. Interesting. Okay, so that is the Macaulay duration for the example that we had. Any question? So it's kind of like equal to 3 because the last payment at time 3 is heavy. Now, the second example, if you have a 0 coupon bond for 5 years, then the Macaulay duration for it will be equal to 5. If you have a, so for 0 coupon bond, the term is the Macaulay duration. Just imagine this cash flow. If you don't have the 10, don't have the 20, don't have the 30, only have that 1,000 payment, then the 1,000 will have a present value of 1,000 over 1.03 power 3, and that's also the present value. So it's 100% of that time 3, right? And there's no other time, there's no other cash flow. Of course, Macaulay duration will be equal to the term, the cash flow. Any question? Right. Let's talk about in the text, there's a shorter formula to calculate the Macaulay duration for a coupon bond. I try to use that formula. Then feel like it's a little cumbersome to remember all this notation. I'd rather draw the whole cash flow and actually look at the present value of the cash flow and find out the percentage of every cash flows in the present value calculation. So, but if you feel like it's okay, you can apply this formula for your Macaulay duration calculation. The textbooks already summarize that notation as a Macaulay duration for coupon. All right. What if you have several things? You have a 0 coupon bond and then another portfolio. So maybe you have a set of things that has different duration. What will be the total duration? Everything, right? So here we're going to use the example. Portfolio of asset has 3 bonds, and the bond A had a price of 2,000. The Macaulay duration is 9.5. Remember, the price of anything is the present value of it. We already have the present value for A, B, C. Bond B has the price of 3,000, Macaulay duration of 9.0. And bond C has the present value of 5,000 and Macaulay duration of 16. So how do we calculate the Macaulay duration for the whole portfolio? It will be a weighted average of those duration. So essentially, you're going to take those duration and then have a weighted average. So the 9.5 will have a weight of the 2,000 over the whole price. Here are the calculation. So the total price or the total present value is adding up all the prices. We got 10,000. All right, and then for 9.5, the weight is 2,000 over 10,000. For 9, it's 3,000 over 10,000. And then the 16 is 5,000 over 10,000. You calculate the weighted average of all the duration, which gave you 12.6. Any question? Talking about combination of a couple of financial products. What do we talk about? But sometimes you invested into different things. You have a 2-year 0 coupon bond, then you have a 5-year 0 coupon bond, then you have something else. And you might want to find out for all your assets, all your financial assets, what's the total duration. All right. So summarize what we're talking about, the Macaulay duration of a portfolio is a weighted average of the Macaulay duration of the individual asset, if you know the Macaulay duration. The weight given to the duration of an individual asset being the portion of the total price attributed to that asset. The same statement can be talked about the modified duration. So the modified duration for a portfolio equal to the weighted average of the individual modified duration. So it doesn't matter which type of duration are we talking about for a portfolio, you can always find the weighted average of their corresponding duration. So this is the example about another example, duration of portfolio bonds. So Julian have a portfolio that has 2 bonds, 10,000 5-year 0 coupon bond and 2,000 6% per value 2-year bond. okay? And we want to find out Macaulay duration of this. This is the example in our textbook. So how do we do? You get 2, all right? And then we're going to calculate their duration and price for both. For the 5-year zero coupon bond, you know the duration is 0 coupon bond. That means there's no cash flow before the last, not the last cash flow. Of course, the length of time for that cash flow is your duration. So duration for the 5-year bond is 5. Price is going to be the future cash flow, which is 10,000 discounted to time 0. We find out it's 8,000 over 24.51. Now about the 2-year bond, that's a little bit different. And we have par value 2-year bonds with semi-annual payment. Then its par value, so the redemption equal to 2,000. So you have your cash flow 2-year bond, semi-annual coupon. So that means you have 2 times 4, 2 times 2, 4 coupon. And then it's semi-annual, so the 6% divided by 2, 3% in each coupon. So 2,000 times 3%, we have 60. So 60 cash flow at every coupon payment for them. So 60 divided by 1.45 to the 0.5 power, 60 divided by 1. So you discount all the cash flow back to time 0. And that's our total price. Any question? So we would determine the total price, and then that price is the total present value. Now, individual value has to divide it by the total present value to find that percentage of the time. So our cash flow occur at half year, 1 year, 1.5 year, and 2 year. So all those time has to be a weighted average multiplied by their weight, and then you get the total weighted average of 1.9157. That's the way for the second duration, the second asset in the portfolio. So the 5 and 1.91 has to be calculated again. We want to find the weighted average among the entire portfolio. The last calculation is the Macaulay duration portfolio. Any question? So that's the example in the text, and also explain how we determine individual Macaulay duration and how to determine the Macaulay duration for the entire portfolio. They're not the same, but they kind of all follow this similar idea. Okay, so that's the calculation. All right, so let me explain a little bit more about the calculation that we did. So far, we were devising a numerical formula for the calculation for Macaulay duration. I haven't really talked about the modified duration. So what's exactly how to calculate modified duration? In the text, it's actually explained more extensively. I did not follow the textbook because I feel like there's so much function notation, so long to talk about. So there are 2 definitions for the modified duration. One is if you have your present value formula calculated based on the interest rate. Let's call that PI. PI is the present value based on the interest rate I, right? If you have a formula for the present value, and you can find the derivative of that PI, then modified duration is negative derivative PI divided by PI. It's like a percentage of the derivative, if that means anything. The price formula with the interest rate is a decreasing, because you have to calculate present value. So say 1 plus I to a negative power. That's why it will be a decreasing function in relation to I. And that's why you find derivative PI, the derivative P prime I is negative. So you have to put a negative before it, so the modified duration will be a positive measure. Now there's a relation between modified duration and Macaulay duration. The Macaulay duration divided by 1 plus the interest rate per payment period divided by 1 plus I actually is the modified duration. So you can also think of Macaulay duration equal to modified duration times 1 plus I. That I has to equal to, if it's an equal payment, is that the interest rate in between your payment period. And I write Y over M here. The Y is the annual yield. If you have M payment per year, you have to take your annual yield divided by M. That's really the interest rate per payment here. By. So basically, Macaulay duration is modified duration times 1 plus I, or modified duration for Macaulay duration divided by 1 sine. Any question? And let's look at a couple examples where this will be talked about. So the modified duration, this is now we're gonna talk about. Almost like, at least let me talk about Macaulay duration for perpetuity. If you have a perpetuity, then the present value calculation will be 1/i. So what's your Macaulay duration? There's two ways to do this. For one, you can, if present value is 1/i, you can find the derivative. Derivative 1/i is negative 1/i squared. So the modified duration is negative p prime I over I, which then is 1/i. So the modified duration is actually 1/i. And therefore Macaulay duration will be 1/i times 1 plus I. That's for perpetuity immediate. Now, if you have perpetuity due, then the P of I equal to 1/d, which equal to 1/i times 1 plus I. That's 1 plus I over I. The I is being capital, it's supposed to be lowercase. Now, so then the derivative of this will be negative 1/i squared. So the modified duration is 1 over, in the denominator is I times 1 plus I. So then the Macaulay duration will be the modified duration times 1 plus I, which then is 1/i. Okay, that's for perpetuity due. I realize I was supposed to. Right, this is perpetuity due and perpetuity. That's perpetuity due. So this is really using the present value formula if you have that formula. And then here is what is the cash flow. If you have perpetuity immediate, then PV equal to 1/i. So the modified duration will be weighted average of the time. I mean, that's supposed to be like 1 times V over 1/i, and 2 times V squared over 1/i, 3 times V times 3 V over V3 over 1 plus I, and then plus 4, 5 times V to the power 5 over 1 plus. This is the infinite summation. I failed. I finished the rest of the dot dot dot. It was supposed to be 3 times V to the power 3 sine. And this is really an infinite summation equal to 1/i anyway. We're out of time, but the file is online. We're gonna continue on Thursday. But I think I kind of went through the most of the idea on duration and swaps. Thursday we probably finish talk about duration and immunization. That should have finished all the topic on chapter 8 and 9. So basically, we want to be able to calculate the swap rate, be able to determine duration, and be able to determine the immunization. That's it for today.
Chapters with the test right at you.
I think it's everything.
Okay.
There's an example of mine. Okay.